right. Okay, so we're live. So we will wait for people to join in. We'll probably start at the 2-minute mark.
Sure.
But hi, everyone. Thanks for joining. My name is Nicole. I am the Senior PMM Product Marketing Manager here at DigitalOcean. And I'm joined here today by Akshay. I will let him introduce himself in a second here, but I just wanted to go over the topic today. We'll be talking about serverless inference in production, and you will learn how to deploy fast, cost-efficient AI workloads with DigitalOcean's Gradient AI platform. So a lot of exciting stuff today. The main focus is going to be serverless inference, and we're going to talk about those workloads in production. So if you are new to DigitalOcean, we are a inference cloud, and we follow 3 principles: simple, scalable, approachable. We believe that cloud infrastructure should be all of those things as to not act as a barrier to entry to anyone wanting to build on the cloud. So without further ado, I will hand it off to Akshay. Akshay, if you want to introduce yourself, I think that would be great as people start to join in. So go ahead.
Sure. Thank you so much, Nicole. Thank you for the introduction. Hello, everyone. My name is Akshat, and I'm a Senior Solutions Architect here at DigitalOcean. Have been at DigitalOcean for around 3.5 years now, working closely with customers, helping solve their problems related to infrastructure setup, cloud environment, with startups and with the small medium industries, right? And I'm so glad that you found some time from your busy schedule to join the webinar. So thank you, everyone. Thank you for joining. Shall we begin, Nicole? Are we good to begin?
Yes, please go ahead.
Perfect. Okay, so we all know AI adoption is expanding, right? But the challenge is to run inference at scale without managing GPUs or burning through budgets or cost. So in this session, we will deep dive into serverless inference, which is a modern approach that lets you deploy and scale AI workloads on demand without provisioning or maintaining infrastructure. We will also follow with a quick demo that will showcase how easy it is to deploy and invoke a model using serverless inference endpoints. We will explore practical deployment patterns for LLMs, for text-to-image models, etc. And by the end of this talk, we will understand how to run production-grade AI workloads with minimal operational overhead and significantly lower cost. Okay, so let's see what are the agendas that we'll be following. So we'll first talk about serverless inference. We will understand the traditional method. We will understand the difference or comparison between serverless and server-based inference. Why someone should choose serverless inference? What are the benefits, use case, ideal case scenarios, how it works? And then we'll look into DigitalOcean's gradient implementation, how the serverless inference works or can be used with DigitalOcean, following with live demos in the Q&A session, right? So let's first talk about the traditional setup. So traditionally, companies deployed machine learning models to server-based inference. They used to provision dedicated servers or virtual machines, and then installing all the necessary frameworks, managing the entire infrastructure life cycles themselves. So companies hosted the models and were responsible for all aspects of availability, reliability, scaling of these models. This managed approach applied primarily for the open source models. However, if we talk about the proprietary models from OpenAI or Anthropic, it has its own complexities and typically requires direct integration with their APIs. So this approach demanded significant DevOps expertise to handle capacity planning, scaling, security patching, and monitoring. With all this, you also have to manage the cost of keeping servers running during the period of low demand as well. So scaling is another thing that you have to handle, right? So if I have to put it in bullet points, these are the challenges. Provisioning and managing GPU servers, complex infrastructure setup and scaling logic. You need DevOps expertise for availability and reliability. And then you have to manage vendor accounts as well for the billing system or for various providers that you use for the setup. So they might have separate billing that you will have to manage as well. Okay. So moving along now, let's deep dive and try and understand a little bit more about serverless inference. So, serverless inference is an approach of using machine learning models that eliminates the need to provision or manage underlying infrastructure and still enables applications to access AI capabilities. So, instead of running models on dedicated servers that you have to maintain yourself, you can simply make API calls to managed service. It allows developer to call powerful models through straightforward API calls without managing any underlying infrastructure. So scaling automatically can work while only charging you for actual usage. So it will scale up and down and you will only be charged for the actual usage. You pay only for the tokens used during inference. So there is no problem or scenario of idle servers or no capacity planning headaches and no infrastructure maintenance overhead as well. Let's try and understand a little bit more with this real world example. So, one goal with this webinar is I want to make it more and more relatable with the real world examples and business cases that serverless inference can solve. So, let's say we have a SaaS analytics startup company that wants to add natural language query capabilities to their dashboard. And they might hesitate to use the complexity of maintaining machine learning infrastructure, especially when the customer usage fluctuates throughout the month. So with serverless inference, they can simply integrate API calls into their existing applications. And they can quickly start providing data analytics without infrastructure charges or specialized expertise on that particular topic. Right. Another example can be a maybe a developer that might want to integrate OpenAI GPT models into their customer support chatbot. So they can do it by making simply API calls that generate responses based on conversational history or supported documentation. Similarly, an e-commerce site or website could upgrade their product search by implementing Anthropic. So they can just use the natural language queries without having to manage any of the underlying model or infrastructure. Right. So this is where serverless inference comes into play, and there are major cloud providers providing serverless inference kind of a managed service. Just to make it more relatable and you understand where it all fits in, I just want to mention few of them. AWS has AWS Bedrock. GCP calls it Vertex AI. Azure has AI Foundry, and DigitalOcean calls it Gradient AI Platform. So these are all the serverless inference managed service provided by various different cloud providers. Okay. Now moving along, so now that we have understood the serverless inference simplifies AI implementation by removing traditional barriers, let's also try and discuss the benefits of adopting serverless inference. What are the advantages over traditional deployment methods, right? So we'll start with maybe zero infrastructure management. So as we have talked, there is no server provisioning needed. Hence, it eliminates the burden of engineering team with configuration and initial setup time and setup or configuration requirements, right? Apart from that, it also is freeing developers from security patches or framework updates and deliver maybe driver compatibility issues as well. So during the full infrastructure setup, there can be a lot of things that can go wrong or that might need extra interventions and setup, right? So you are completely saving on the infrastructure part. There is no headache of infrastructure at all, right? Next step is automatic scaling. So serverless platforms handle the complex scaling resource up during the traffic spikes and down during the lower traffic or null traffic without any manual intervention. So automatic scaling is something that Inference will take care of. This elastic scaling happens behind the scenes in seconds that allows even small applications to handle unexpected viral load or seasonal demands without performance degradation. Let's also talk about cost and pricing. I do understand that is very essential, correct? So companies pay only for the milliseconds of compute time actually used during manual execution, with no charges occurring during quiet period. So you only pay for the time that you are using. For the time there's no inference calls or no tokens used, you will not be charged. And this can be highly beneficial for applications with bursty traffic patterns compared to the maintained dedicated GPU instances that sit idle much of the time. So you are only, so let's say there's a scenario where you have bursty traffic at momentarily some time of the month or some time of the year or some time of the day even, right? So you only have to scale up and down at according to that. You don't have to maintain the full dedicated GPUs instances, which will be sitting idle for maybe the rest of the time. Okay. Another advantage is simplified model maintenance. So developers can access numerous models from various providers through a single consistent interface and single authentication system rather than maintaining separate accounts and different API keys. This unified management layer eliminates the complexity of handling rate limits, token quotas, billing relationship with multiple AI vendors, etc. So you do not have to take care of those complexities and those details at all. It also helps you reduce time to market. So let's say you are a product team or you're a product company and you want to integrate production ready AI capabilities into existing application. That can be done in days and it will eliminate the time used for the entire infrastructure planning and deployment phase. So this eventually and overall accelerates your development cycle and allows you for faster experimentation, more rapid iterations, and quicker validations for AI features with your real users. So as soon as you go live to the market, you start using users, you get real users, and you can test it with them. You get better feedbacks, better understanding of what customers are looking for or what your users are looking for, right? So it makes it easier to go to market faster. Correct. So these are few of the advantages. After advantages, I want to take care, I want to explain a little bit, do a comparison between server based and serverless inference. I think most of us here now have a little bit of understanding what server based inference will do and what serverless will. With the server based inference, as we understand, it requires server infrastructure. So you have to take care of GPU setup, all the configuration that needs to be done, all the deployment that needs to be done, maintenance that might come in the future, correct? So you have to take care of the infrastructure. You will also have to take care of manual scaling and provisioning. So you won't have the option of scaling up and down automatically. So you will have to take care of the infrastructure to scale up when you need more resources and scale down when it is lesser resource, because of course we all know how expensive GPUs can be. So we have to take care of that. There will be higher operational overhead for the 2 points that we mentioned above. You need someone to take care of the infrastructure throughout the day, throughout the month, right? So there's additional operational overhead. But with server-based inference, there are a couple of things that can work in your favor. So if there is a situation where you need specialized or consistent workload, you know the traffic will be consistent, you are aware or you have a team who can handle it. And if there's a scenario where you need full control of the environment, right? So in these scenarios, you can use server-based inference. However, when we talk about the serverless inference, there is no server required. It is a fully managed environment, right? Out of the box, you can start using it. You can start using the API, you can start calling the models, and you can start using it. So you don't have to worry about the underlying infrastructure and setup. It takes care of the automatic scaling. Depending on which provider or the model you are using, it will automatically scale up and down. That results into lower overhead, which means you can focus on the app logic. So you do not have to need manpower or resources to take care of the infrastructure. You can always have a team build which is AI ready and wants to focus on the application that you want to develop for the customer or use for the customers, right? So the focus can be completely on the app logic and not on the infrastructure. It is best for the variable and bursty workloads where the traffic can be spiking and different, and maybe you're in a testing phase and you're not sure of how the traffic would be, correct? And you get less control but simpler integration, right? So the operational simplicity that you get with serverless inference makes it easier to enter into AI adoption, which is very valuable for startups, rapid prototyping phases, or organization without dedicated machine learning operation team. It's also ideal for companies that prefer to allocate their engineering resources towards building AI applications rather than investing in specialized infrastructure management capabilities. Okay, so that is about it. And again, to make it more relatable, I also want to bring a few ideal use cases where the serverless inference could be a perfect fit. Who could be looking for those, or who can use serverless inference to integrate AI simply and quickly? So I will share examples from various different industries and fields, right? Maybe a SaaS application or a SaaS company can use tools to add document summarization for tone checking or language enhancements, right? Maybe an e-commerce platform can implement smarter search, personalized recommendations, and dynamic support. For a content creation platform, they can offer real-time AI-assisted writing and editing features. Excuse me, editing features. EdTech companies can deploy dynamic tutoring or grade systems powered by LLMs. And same goes for customer service providers also. If you're a customer service provider company, you can automate common support tasks and responses with AI integration, right? So these are few of the ideal cases where serverless inference suits best and can be used best. Okay. Moving along, now that we have understood so much about serverless inference, I would like to highlight and talk a little bit about why to use DigitalOcean inference and where does it fit in or is beneficial for the users. So all the benefits that we talked about with serverless inference, you get all of those with DigitalOcean. To name them, you get unified access key for all models and vendors. So you create one access key, and we will see that in the demo section as well, right? You create one access key that gives you a simple authentication, which can be further used to access any of the models from various different vendors. You get single API endpoints. You call one API endpoint and then use any of the models that talks to that particular endpoint. So it is an easy integration across models. You get centralized billing. So with the DigitalOcean serverless inference, you get one bill where you get bill for other resources as well as serverless inference. And irrespective of how many models you are using, you might be using a model from Anthropic, you might be using a model from OpenAI, you get one centralized bill. So you do not have to hover over maybe different PDFs and different bills to understand what was your monthly bill at the end of the month, right? So you get one centralized bill where you can identify how much was the cost for various different inference models you were using or the input tokens and the output token used across the month, right? You also get cost advantages for many workloads. So again, discounts are one part of it. Other section is DigitalOcean partners with a lot of model providers, right? So you might get better pricing as well when you are using serverless inference models through DigitalOcean, right? And it does support major models like OpenAI, Cloud, Llama, etc. And there's wide model support, and we will also be adding very soon a lot more models as well. So this is a gist of what are the benefits of why you should be using DigitalOcean inference. Now that we have seen that, and before we go into the demo, I would also like to just give you a gist about how to use serverless inference on DigitalOcean's Gradient platform, right? So as we were talking about earlier, you have the option to generate access key. So you can create an access key from DigitalOcean's control panel or from the API as well. Okay. And after that, you can go ahead and call or use the serverless inference API. So to use serverless inference, you need to authenticate your HTTP request with the model access key. You can create a model access key from DigitalOcean's control plane or API. So this is the API address, which is inference.do-ai.run. And this is example of couple of API endpoints like v1/models, which will list all the available models, and then v1/chat/completion that will give you the prompt and you will see the output from that, right? So that is how you can use it. And then you can further connect it with clients and SDKs as well. We will anyways go through the full demo of understanding how it works, right? So yeah, this is how the gradient AI on DigitalOcean works. Let's see what other things we'll cover in demo. So everything that we have talked, first we will create an access key. We will go to the DigitalOcean's console, and from there we will create an access key. Once we have created access key, we will use the one of the endpoint, which is v1 slash what was that, v1/get model, where we will see all the models listed. We will again show inference in action, where we will be doing chat/completion to see the input and the output tokens. And I've also created a full-fledged application using serverless inference API endpoint call using the FAL model, which will be a text to image generation. We will enter a prompt in the application and it will generate an image for us. And last and final, we will do model comparisons. So DigitalOcean Serverless Inference has a feature of model comparison that might help you understand which is the best fit model for your application, for your use case. So I will demonstrate that as well. So I think we are good to start with the demo, right? So let me share my different screen. Let me just confirm if it is visible. Okay. Perfect. So we are on the DigitalOcean console. As you can see on the left-hand side, there are a lot of options or the services that DigitalOcean provides: agent platform, droplets, GPU droplets, Kubernetes, databases, etc. Right? For this particular webinar, our focus is on agent platform. So when I click agent platform, I will reload this page. Once we click on agent platform, we are focused and our topic today is serverless inference. So we'll go there. Now this is where you see the options. You see the model endpoint, the one we were talking about, which is https inference.do-ai.run, right? So this is our model endpoint. And if you click on about endpoint, you will see all the details about the endpoint API calls. So this is what I was showing you in the previous slide as well, v1/model, and then chat completion and response and async invoke for calling the file models. Okay. Now, but before we do model endpoints or call the model endpoints, we first need to create the model access key. For this particular demo, I already have one created, which I'll be using, but I'll just showcase how you can create a new model access key. So you can create model access key, you can give it a name, maybe just webinar test. Now, the most important thing I want to highlight here is the list of all the models. So one key will have access to the following models, okay? Now, all the models that are available is listed here on the left-hand side, and on the right-hand side, you can see the transparent pricing of input token per million and the output token per million. So it is very well giving you a clarity of what will be the price based on each model. So depending on your budget, depending on your application's use case, you can select the right model fit for you, right? So if you click on add model access key here, this is how the model key will be created. This is the secret key that will be generated. You can save it and you can use it later on. So once you have the model access key created, on the right hand side, it also makes it easy to understand the syntax and how to use it. And you can use these many developer tools. You can use Gradient SDK, you can do Python coding, integrate with Python, JavaScript, or you can also do curl commands or curl requests to these API endpoints. Just to iterate and go into a little bit of the syntax. Now you see you are sending a curl request to inference.do-ai.run/v1 chat completion. Okay. So this is the API endpoint that you will be reaching out to. Now this is the authorization bearer token, which is the model access key we just generated. Then you give the model name. So as you can see here, the list of all the models are again mentioned here. As of now, GPT OSS 120 billion is selected. So this is what you see as the model. And this is just a prompt that you are seeing here. What is the capital of France? And then this is one of the variable that we are using, which is max token 100. So the output token can be fixed if you want to maybe keep a track of the max token or the token that should be used. So you can set that value as well. Now you can see OpenAI GPT OSS 120 billion is here. If I change and select maybe Llama 3.1 instruct, the model name will change here, right? So this is how you will see the syntax here, and that is the exact same thing will happen if you select Python or Java, right? Now let's get into action. Let's see them working live. To show this live, I am using Postman for the API webhook calls. The first model or the API endpoint that I want to highlight is inference do-ai.run v1 models. If you remember, let me show you the screen again. So this model endpoint, it will be used to return the list of available models in their IDs. So we'll be doing a get request. going back to Postman. So I have get request set. This is my model endpoint. I click send. It should show me the list of all the models that DigitalOcean has to offer. So this is the ID, the various IDs of various different models that DigitalOcean has to offer. Now using these IDs, you can further do API calls as well, right? So you see all the list here. So we did test v1 slash model. Now let's try and check the chat completion model as well. Okay. So this is the API endpoint that I'm calling. I'm sending post request. The model that I'm using is Llama 3.37 billion instruct. And the same content that I'm using is what is the capital of France. So if I send a post request to this API endpoint, we should get an output. We should get an answer from the Llama 3.370 billion instruct model. Let's see what happens. So yes, we are seeing the output, and the output content is the capital of France is Paris, right? So this was my input token, and this is now what I see is the output token or the output using the LLM model Llama 3.37 billion instruct. This is one example. This is one part of the thing that I'm showing where I'm highlighting, or I have highlighted couple of API endpoints. The one interesting one that I want to showcase now is using the FAL model. So FAL gives you access to text to speech or text to image kind of LLM generation, right? Now the post request goes to v1 async invoke. It is also documented very well in our documentations. This is the exact same that I'm using the endpoint, right? I'm sending a post request to v1 async invoke. Let's see what happens or how I can use it. So the model ID I'm using is FAL AI fast SDLX. The prompt I'm giving is a dog playing with the cat. So this model is used or will be used to generate image from this text prompt. Okay. So when I click on send, it should generate a request ID. Using this request ID, I will further go ahead and check the file output. This is the request, get request that I'll send to get the output. Now, once I send this, my image is ready. This is the URL where the image is. Let me click on this URL and let me show you the screen. So as per my prompt, a dog playing with the cat, this is the image that was generated by the FAL model, FAL AI model, right? Fast SGLS that we used. Now, this is all I am showing you right now on Postman, right? So this is just doing web calls. Let me show you a fully fledged developed application using the same file model, which will, in the application, we will add a prompt and we will see the image generated, okay? Let me share my screen here. And how I have developed it, I have my code written, which is on GitHub, and then I have hosted the front end on app platform. So let me go to the app platform screen. And this is the application that I have developed. This is my front end. This is where the application is hosted. This is the one where you can see my mouse hovering. This is my address. Now, let me first show you a little bit about the code that we have developed so that it becomes more familiar to understand. So this is the GitHub from where repository from where the application is getting pulled. Let me go to that GitHub repository. You can see this particular repository is hosting a text to image generation app, right? Which uses FAL AI's SDLX model via DigitalOcean's serverless inference API. Okay. I will just show you one part of the code just to understand how it can be integrated within the application. Okay. So this is where my code lies. Let me zoom it a little bit. Okay. So we have the environment variable set up here. So it is doing calling the model access key. We are using the model access key, the one we generated on our console. This is the API base URL, the one that we have been seeing for some time now, the inference.do-ai.run/v1. So this is the base URL. Now on Postman earlier, this was the URL that we use, the API endpoint, which is async invoke, the exact same I'm using here. The same model I'm using in this application as well, FAL AI fast SDLX. This is the input that we'll be receiving from the application when I show you, and then we are seeing the output here. And this is the authorization header that is all we can use. A developer will be able to understand how to set it up. We have this all in our syntax as well. So let me go back to my app platform. This is the URL of the application where it is hosted. Let me click open this. Let me share this tab. So this is the look and feel of my application. This is what you can see. I do have some advanced settings just to make it a little fancier. So I will set the inference step to highest and guidance scale to highest to get the best result output. I will use one of the prompts here itself, a cozy cabin in snow mountains with warm lights. Let me select that and click on generate image. So what is happening at the backend? It is calling. Okay, so the image is generated now, right? So exactly as we prompted, we have an image generated. Let me go back a little bit and show you or and explain you how and what is happening here. So this application, which is hosted on GitHub, is using DigitalOcean's serverless inference endpoint. Using that serverless inference endpoint, it is calling the FAL AI's fast SDLX model to generate image from the prompt that we gave, right? So that is how it is integrated right now, and that is how it is using it. So we can use that model, and we can use any model for that matter, and we can develop our application the way you want to use it. Okay. Moving along, let me come back to DigitalOcean, and the last part of our demo was to showcase the model comparison. Again, this is very essential and will be very helpful for customers who are testing right now and trying to understand the best fit for their application, which will be the best model for their application, right? So again, going back to the serverless inference, you see here the option of try and compare models in model playground. Okay, so when I click this, it will show me a page where it's called model playground, and I get the option to choose another model. So what it can do or what it will do is I can give prompts here, and it will give me the output based on various different models that I select. So let's say I have selected OpenAI GPT OS 120 billion here, and give a prompt: what are the seven wonders of the world? So let's see what output or how we see the output from OpenAI GPT OSS. So this is how we see the output from OpenAI GPT OSS 120 billion. So for the application, you are still trying to decide which will be the best fit. So you want to compare with another model as well. So let's say you want to see with a small parameter, which is 8 billion parameter, Llama 3.1 instruct. If I give the same command or the same prompt, how or what is the output that I see? So this is the output that I see on Llama 3.1 instruct, right? So this is how you can compare models, try and understand which is the best fit for you. Maybe DeepSeek could be more of a reasoning kind of a model, right? So if it's something where you need higher reasoning power capabilities, you can use that. If you need maybe a model which is okay with 8 billion parameter or lesser parameter, you can use that. So this can be used for the comparison to understand which is the best fit for your application. Okay. So this is all I had in demo. I will go back to sharing the screen of the presentation. Let me see if you are seeing the right screen. Okay, perfect. A couple of more things that I want to highlight. Now that we have the demo done, we have a good understanding of what application or how the serverless inference works. I also want to talk and highlight a little bit about the uh, real world production deployment. What are the best practices? What are the four pillars for serverless inference successful setup? Right. Model optimization is very essential. Cold start minimization, auto scale planning, and robust monitoring. So these are the four pillars for a good real world production deployment of serverless inference. Let me break down each one of them a little bit. When we talk about model selection, you can always start small. You can start by using a 7 billion or 13 billion model for simple tasks to cut latency and cost. You can scale later on with 70 billion plus parameters when you need the better reasoning power or you need actual production workloads to be taken care of. Serverless model warms up on first use. So for predictable traffic, you can send warm-up requests. For spiky loads like chatbots, you can use async patterns. Auto scaling is very essential. You need to set reasonable concurrency limits. DigitalOcean handles thousands of requests per second automatically, but you can plan for token budgets for high volume burst as well. So let's say we were seeing on Postman also had set a max token limit of 50. So those things can also be used for better track of the request per seconds as well. You can also consider dedicated throughput for mission critical apps. And then very important is monitoring as well. You can track token usage, latency percentiles, error rates. So log every request for debugging. These practices ensures your serverless inference is production ready from day one. Just to recap couple of things, the most essential part. This is the UI that we looked into. This is where you see the agent platform mentioned. Now you click here, you go to serverless inference, and then, sorry, my bad. And then you create the model access key. This is the model access key we used. And on the right hand side, you get the exact syntax depending on what kind of coding language you are using, what kind of model that you want to use, you will get the syntax there and you can use it with the application to just do the API calls, right? And last, the game changer that makes DigitalOcean serverless inference so powerful, the one key concept. No more juggling multiple vendor accounts, no separate billing, no different SDKs. One key, one dashboard, one billing. Switch models mid conversation if needed. There's no problems at all. So this is the building block of true serverless inference. Zero infra management, model flexibility without vendor lock, predictable token-based cost, and production scale from minute one. Right. So this is the most important part that I wanted to highlight, and you get access to all the models, LLM, GPT, Cloud, Mistral, etc. Right. One key. So that's a wrap. Thank you. Thank you all for joining today the webinar on DigitalOcean serverless inference. You now have seen how to deploy production grade AI capabilities in minutes without servers, without DevOps overhead, and with pay per token pricing that scales with your needs. Whether you are building chatbots, content workflows, or intelligent search, this is all you can use DigitalOcean's gradient. It makes it simpler to access top models like Llama, GPT, Cloud through one unified API. I will now hand it over to Nicole to talk a little bit more about how they can use DigitalOcean.
Great. Thank you so much. So as you guys can see, there is a QR code. If you want to go ahead and grab your phone to snap a picture of it, it'll lead you to our website where you can fill out the form. And this form will connect you to people like Akshay, our team of solution architects, and they can help you discuss anything related to migrations, answer any questions you might have, etc. And right now at this time, I want to go ahead and say, if you have any questions, to please put them in the comments and we can get to them. I know that I have some questions, so I'll get to those at the end, but Akshay, if you could just go to the next page. Thank you so much. Okay, so I also wanted to include like a more specified next step for you all. So if you are not a customer of DigitalOcean currently, I want you to scan the first QR code that's up there. You actually qualify for $200 worth in credits to try DigitalOcean and also to try the products and platforms that you saw today. So everything that Akshay was showing you, you can go ahead and get started with yourself with these credits. And then if you are a DigitalOcean customer, the second two QR codes are for you. You can scan the second one to, again, get connected to experts like Akshay. Our team of solution architects can help answer any questions you might have. And then if you have any other questions that don't fit, or you feel like the first two next steps don't fit kind of into what you're looking for, then we can just direct you to sales and they can help you with pretty much anything you want to know. So that's the third QR code. And then if you want to go to the next slide, Akshay, please. Thank you. So I will post these links in the comments, but this is just some more information for you all. So we have some tutorials and some pricing information, as well as just some how-to guides on how to get started. So I will post these for you. I'll post the actual links. Um, but in the meantime, I didn't see any questions in the comments, but I did have some questions myself, and these, are pretty, I'd say, applicable questions, so they can continue the conversation. But the first one, Akshay, is what type of workloads would you say are the best fit for serverless inference versus traditional GPU deployments?
A very valid question, Nicole, and I highlighted earlier as well. So one thing that is very essential is something where you are not sure about the traffic, right? There can be scenarios where you have bursty traffics and scenarios when you have less traffic, right? So those kind of scenarios are best treated or best suited for serverless inference, because then uh, you do not fall into a trap or a situation where your GPUs are idle, and we know how expensive GPUs are. So we want to make sure we are using it at full capacity, right? So if there are scenarios where you want to maybe create an documentation summarization kind of a tool, right? Which you will not need throughout the day or every single day kind of a thing, right? So those things can be helpful. That will be one of the scenarios where you need it. Maybe a support task that you want to do. So these are the situations where you can use serverless inference for sure. And it will also make you go to market very soon. So
Okay,
they're very helpful.
interesting. Okay, yeah. I know that we touched up on that on the webinar. I just wanted to follow up. And then, so here's a question I was thinking about during the webinar that has to do with Kubernetes. So for
Mhm.
teams currently, say they're running inference workloads on dedicated VMs or Kubernetes. So what's the easiest way for them to get started with serverless inference? Or is there a first step that you would suggest?
So serverless inference is a complete managed service, so it is out of the box supported. So what we saw in the demo, it is something where you do not want to take care of the infrastructure, which in case of Kubernetes you do a little bit. So you can just go to our agent platform and create a model access key, and voila, you are ready to use the Inference API, and you have the list of all the models that are available that we showed. I mean, I can show that again here. This is the list of all the models that we have. So we have various models from Alibaba, Anthropic, DeepSeek, FAL. So any of these models that you want to use out of the box, Kubernetes or setting up your environment might be very beneficial if you are using your own model. If you have created your own LLM and your own trained model, then yes, you can set it up there. But if there is already available public models that you want to use, serverless inference suits best for you. These are the list of all the models that you can see. And if you want to use them, you can just get the new API key and start using the endpoint.
Okay, interesting. And uh, do you think that products like DigitalOcean MCP server uh, that includes Kubernetes endpoints would also be, a good thing for interested customers to look into?
100%, yes. So
Okay.
Kubernetes or the MCP servers are also a good option for. We do have the MCP support throughout, so that's also a good
Mhm.
thing to look into. And yeah, as you were mentioning, Kubernetes also suits best, and that gives you the freedom of running your own model as well. And we are also very soon coming up with dedicated inference. So what we have been seeing right now with the managed service on serverless inference, that gives you access to these proprietary models or publicly available open source models. Now, if
Mhm.
there's a situation where you want to run your own model, you want to bring your own model, but still do not want to get into the overhead of infrastructure management, that should be possible very soon as well.
Okay, interesting. And then one more question I had was, what do you think are some mistakes that teams make when deploying inference workloads for the first time?
Interesting. I think the most important thing would be testing and choosing the right fit. That's something that I do understand needs some time, because I do understand it can be overwhelming seeing these many models available, right?
Mhm.
So we need to have a clear mind understanding which is the best fit for our inference, serverless inference. Second thing is keeping a check on the max tokens or the token utilized. So ultimately, I understand everyone using AI is very concerned about the cost, right? So keeping cost track is essential. So you have to keep a track of the tokens being used, whether that be during the testing phase or the production phase. So it is very important you keep a track of the input token and the output token. So for the output token, you can always have your application set with a max token limit, which I think is kind of a stopwatch or a stop clock that you can set, right? So that I think will keep a very good track or check on your max token utilization and will keep a check of the cost as well.
Interesting. Okay. I think that will be helpful. Okay, so we're at time. We're at 45 minutes. I just wanted to let everyone know, I know that there was a ton of links in the comment section, but I just went ahead and put all the links for you so you can copy and paste it into your web browser. These are just informational links for you, like tutorials, how-to guides, pricing pages for you to learn more. So please look at those at your leisure. And again, you can just type in anything here and it should pop up on Google. All right. Well, that's it. Thank you so much. If you guys have any questions that you didn't get to ask, then please fill out our contact sales form and we'll be happy to answer them for you. All right. Thank you, Akshay. I appreciate it. That was a wonderful presentation. I know that I really enjoyed it and I hope that you guys did too. All right. Thank you. Have a good day.
Thank you very much. Have a good one. Bye-bye.